Number 1. Sunrise Arc. NASA's James Webb Space Telescope captures WHL-013-708, a colossal galaxy cluster, unveiling the universe's most magnified galaxy in its inaugural billion years, the Sunrise Arc. Within this galaxy lies Earendel, the farthest star ever found, initially spotted by Hubble. Further scrutiny via Webb's NIRCam unveils Earendel as a massive B-type star, over twice as scorching as our Sun and emitting light 1,000,000 times brighter. Earendel resides within a space-time distortion, experiencing intense magnification that renders it visible beyond its host galaxy, which manifests as a crimson blur across the celestial expanse. Detection of the star relies on the synergy of human technological prowess and natural phenomena, facilitated by gravitational lensing. In this depiction, the Sunrise Arc emerges just below the diffraction spike at the 5 o'clock mark. The hazy pale galaxies at the image's core belong to the gravitational embrace of the galaxy cluster. Webb's discerning mirror captures the array of reddish, curved galaxies, distant entities illuminated against the backdrop of space. Number 2. Supernova, 1987A. Webb's NIRCam unveils a detailed snapshot of SN 1987A. At its heart, ejected material shapes a distinctive keyhole form, flanked by recently uncovered faint crescents. Beyond lies an equatorial ring, fashioned from material expelled millennia before the supernova's eruption, adorned with luminous hotspots. Extending outward, diffuse emissions mingle with two delicate outer rings. In this portrayal, blue signifies light at 1.5 microns, cyan denotes 1.64 and 2.0 microns, yellow represents 3.23 microns, orange depicts 4.05 microns, and red indicates 4.44 microns. Number 3. Exoplanet K2-18b. This depiction offers a glimpse into the potential appearance of Exoplanet K2-18b, derived from scientific data. This world, 8.6 times the mass of Earth, orbits the cool dwarf star K2-18 within the habitable zone, situated 120 light-years distant from our planet. Recent scrutiny by NASA's James Webb Space Telescope has unveiled the presence of carbon-rich molecules like methane and carbon dioxide on K2-18b. The prevalence of methane and carbon dioxide, coupled with the scarcity of ammonia, suggests the likelihood of a hydrogen-rich atmosphere overlaying a potential water ocean on K2-18b. In the illustration, exoplanet K2-18c is positioned between K2-18b and its parent star. Number 4. HH-2111. NASA's James Webb Space Telescope offers a high-resolution, near-infrared perspective on Herbig-Haro 2111, unveiling intricate details of the outflow from a young star, akin to our Sun in its infancy. Herbig-Haro objects materialize when the stellar winds or gas jets ejected by nascent stars generate shock waves upon colliding with surrounding gas and dust at high velocities. The image presents a series of bow shocks in the southeast, lower left, and northwest, upper right, along with the narrow bipolar jet propelling them, depicted with unparalleled clarity. Molecules stimulated by the tumultuous environment, such as molecular hydrogen, carbon monoxide, and silicon monoxide, emit infrared radiation, which Webb captures to delineate the outflow's structure. Number 5. Europa NIRCam, mounted on NASA's James Webb Space Telescope, has snapped a portrait of Jupiter's moon, Europa's surface. Webb's observations have pinpointed carbon dioxide on Europa's icy exterior, likely stemming from the moon's subsurface ocean. This finding carries significant implications for Europa's potential habitability. The predominantly blue hue of the moon results from its increased brightness at shorter infrared wavelengths. Notably, white features correspond to the chaos terrain Pauis Regio and Tara Regio, exhibiting elevated concentrations of carbon dioxide ice on the surface. Number 6. NGC 346. This fresh infrared portrayal of NGC 346, captured by NASA's James Webb Space Telescope's mid-infrared instrument, traces emissions from cool gas and dust. Blue hues signify silicates and sooty chemical molecules called polycyclic aromatic hydrocarbons. Red emissions, more diffuse in nature, emanate from warm dust, heated by the region's brightest and most massive stars at its core. Bright patches and filaments denote areas rich in protostars. The image showcases light at various wavelengths. 7.7 microns depicted in blue, 10 microns in cyan, 11.3 microns in green, 15 microns in yellow, and 21 microns in red. Number 7. Kilonova and host galaxy scientists utilize NASA's James Webb Space Telescope to observe the remarkable gamma-ray burst, GRB 230307A, and its linked kilonova. Kilonovas, resulting from the merger of a neutron star with either a black hole or another neutron star, are exceedingly rare, posing challenges for observation. Webb's finely tuned infrared sensitivity facilitated the identification of the celestial origins of the two neutron stars responsible for the kilonova. In this image captured by Webb's NIRCam instrument, the kilonova associated with GRB 230307A and its previous host galaxy stand out amidst a backdrop of neighboring galaxies and foreground stars. Remarkably, the neutron stars were ejected from their original galaxy, embarking on a journey spanning roughly 120,000 light-years, akin to the diameter of the Milky Way galaxy. After several 100 million years, they merged, culminating in the observed kilonova event. Number 8. Crab Nebula. NASA's James Webb Space Telescope has turned its gaze towards the Crab Nebula, delving into the mysteries surrounding its origins. With the assistance of Webb's NIRCam and MIRI, fresh insights have emerged in the realm of infrared light. Resonating with the optical wavelength image unveiled by Hubble in 2005, Webb's observations reveal a remnant characterized by a distinct, cage-like framework comprised of airy, red-orange gas filaments delineating doubly ionized sulfur. Within the nebula's confines, expansive loop-like structures of yellow, white, and green fluffiness emerge, representing regions where dust particles accumulate. Within the nebula's interior lies a region characterized by translucent, milky material. This opalescent substance, emitting synchrotron radiation, showcases a vibrant display across the electromagnetic spectrum, particularly accentuated by Webb's heightened sensitivity and spatial resolution. Synchrotron radiation originates from particles, accelerated to remarkable velocities as they spiral along magnetic field lines. Throughout the vast expanse of the Crab Nebula's interior, this distinctive radiation traces a path, illuminating its surroundings with ethereal luminescence. Identify the wisps within the Crab Nebula, manifesting in a ripple-like pattern within its central region. Nestled at the heart of this ring-like structure gleams a brilliant white dot, signifying a swiftly rotating neutron star. Expanding outward from the core, trace the slender white ribbons of radiation. These sinuous wisps, closely clustered and coursing in varied directions, mirror the configuration of the pulsar's magnetic field. Observe how certain gas filaments adopt a bluer hue. These regions harbor singly ionized iron. Number 9. Stellar Cluster NGC 1833. The stellar cluster NGC 1833 harbors a significant population of brown dwarfs, offering astronomers a unique opportunity to study these faint counterparts alongside the cluster's luminous newborn stars, Webb's potent infrared instruments will be instrumental in unraveling the mysteries surrounding these dim celestial entities. The image presented here is a composite crafted by integrating data from the Chandra and Spitzer space telescopes, complemented by observations from ground-based observatories. Number 10. Reflection Nebula IC 2631. A captivating image from the European Southern Observatory reveals the ethereal glow of blue light emanating from a nascent star, illuminating the Reflection Nebula IC 2631. Situated within the Chamaeleon star-forming region, this nebula serves as a focal point for Webb's upcoming investigations, aimed at delving deeper into the processes underlying the formation of water and other cosmic ices within such stellar nurseries. Number 11. Stephan's Quintet. NASA's James Webb Space Telescope unveils an expansive mosaic of Stephan's Quintet, marking the largest image captured to date, spanning approximately 1/5 of the Moon's diameter. This monumental image, comprised of over 150 million pixels and crafted from nearly 1,000 individual image files, showcases the visual congregation of 5 galaxies, as observed by Webb's near-infrared camera and mid-infrared instrument. With its unparalleled infrared capabilities and exceptional spatial resolution, Webb unveils unprecedented details within this galactic ensemble. Glittering clusters of youthful stars and regions teeming with fresh stellar births adorn the image. The sweeping tails of gas, dust, and stars, drawn out by gravitational interactions, offer a mesmerizing spectacle. Particularly striking are the colossal shock waves captured by Webb's MIRI instrument as NGC 7318b plows through the cluster. These regions surrounding the central galaxy pair are rendered in vivid hues of red and gold, a testament to the awe-inspiring dynamism of the cosmos. This composite image, combining data from NIRCam and MIRI, utilizes 2 MIRI filters to accentuate and distinguish the hot dust and intricate structures within the galaxy. MIRI's observations reveal a distinct contrast in color between the dust within the galaxies and the shock waves amidst the interacting galaxies. To emphasize this contrast, the image processing experts at the Space Telescope Science Institute have assigned a distinct yellow and orange color palette to the MIRI data, contrasting with the blue and white hues assigned to stars at NIRCam's wavelengths.